So if you understand the inverse relation and also you know the concept of functions, so we can look at a more complicated example, example 2. So the question is given an original function, you need to determine an equation of the inverse of it. So first thing first, we can try to figure out the inverse. So basically, you should isolate x. Isolate x. Right? To isolate x, you can minus 3 on both sides. So you get y minus 3 equals x squared. And then you take square roots on both sides. So you should get x. You just switch the two sides. Plus minus. And you get a y minus 3. Okay, so that's first step. And then you switch x, y. So you get an inverse y equals plus minus x minus 3. So you switch to y, so you get this. So done, we got an inverse. And then that's A. B. Sketch the graph of y equals x squared plus 3 and its inverse. So already done. It's easy to sketch, both equations. You can just pick a couple of numbers. Let's start with the first one, y equals x squared plus 3, the original one. So you can pick a couple of points. So x and y, x and y, right? So for example, if you choose x 0 and y should be 3, right? And then you choose the negative 1, and then the y should be 4. And then if you choose x equals negative 2, 2 squared 4 plus 3 equals 7. Okay, so obviously you can also get these 2 points because they're symmetrical. So basically we got 1, 2, 3, and 2, 4, and 5 points. Okay, and then you just reverse the x and y coordinate. So you get a couple of points here. Like 1, 2, 3, 4, 5, right? If you reverse them, you should get this 5 points here. So just connect them with a smooth curve, and you should know this is a quadratic function, so it's a parabola. So when you connect them, keep that in mind, and you should get this. And as we explained earlier, so all these points, they're symmetrical about this line, right? So this is y equals x, so they're symmetrical. So as you can see, each of the point, it is symmetrical about this line. And then that's done. We sketched both functions. And then last question, is the inverse function? Explain. If very simple, do a vertical line test anywhere you draw here except the vertex. There's only one point here, but anywhere else you should get 2 intersections. So the inverse y equals positive negative, right? So that's the inverse. X minus 3 is not a function. Okay, it's not only look at it as a graph, it's actually easier to look at it as a function itself, right? Because for any x except a 3, right? If it's a 3, you get a 0, and the positive negative 0 is the same thing. But anything else, like when x equals 4, 4 minus 1 equals 1, square root equals 1, so you get a positive negative 1. Okay, that's the two values, so it's not allowed for a function. Okay, so and then actually I just want to go a little bit over beyond this example and discuss another questions. So what if we make the question D? Okay, and then asking how to limit the domain of y equals x squared plus 3 in order to make its inverse a function. Okay, if you look at it, the inverse, so if we can cut half away, so then for example, if this part is cut, and then basically we should have a function, right? So to make this half away, and then we have to cut this half away as well, the original one, right? If you cut this half away, so then this part is going to reflect to here. So we have two ways. First, let the domain of the original function x be this way, be great and equal to 0 for y equals x squared plus 3. Now if in that case, if x is greater than 0, basically you can see all the inverse is supposed to be just y equals positive this without the negative, and then inverse y equals x minus 3, right, without the negative one. So basically it's this part, right? It's above the x-axis. Become a function, right? Now you can see, obviously you can drop the other half. So what if we keep you drop the right side and keep the left side? So you have to let the x less and equal to 0 for the original function, and then its inverse will become negative x minus 3, right? So it becomes the other half below the x-axis, and then this one becomes a function as well.